Let's talk about functions as power series. Earlier, we worked with a series that looks like this. I can see we immediately have a typo here. This series starts at 0, not at 1. And if we were at the first few terms of this series, x to the 0 is 1, x to the first is just x to the second is x squared, and this series goes on forever. It has a general term of x to the n, and it goes on forever, like that. And what we had seen earlier was that this series is actually a geometric series. The first term, which we generally call a, that's equal to 1. And the way I go from one term to the next is I multiply by x. So that means that our common ratio r is going to be equal to x, like this. Now, what I want you to notice is that we actually know what the sum of a geometric series is. We know that the sum is equal to a divided by 1 minus r. In our case, a is equal to 1 and r is equal to x, so this becomes 1 over 1 minus x. Okay, so I'm just going to rewrite that down below. We can rewrite this series as, we think of it as a function, so we're going to call it f of x, and that's going to be equal to 1 over 1 minus x. So this is our first example of basically writing a function, 1 over 1 minus x, as a power series, like this. Okay, so thus we can describe a function as a power series. With radius of convergence, in this particular case, of the radius of convergence is 1, and our interval of convergence is going to go from -1 to 1. So what we want to do is we want to reverse this process. In other words, we want to start with a function and see if we can't write it as a power series. We'll also find the radius and interval of convergence of this power series. So really, 11.9, this particular section, is all about writing functions as power series. And we're going to essentially learn 3 different techniques. The first technique we're going to learn is called substitution. So let's take a look at example 1. Example 1 would be a great example of what I call a substitution trick. Okay. Now, when we look at 1 over 1 plus x, this looks very similar to 1 over 1 minus x. In other words, we're going to basically use this 1 over 1 minus x to help us write 1 over 1 plus x as a power series. So let me show you how this is going to work. The first thing I want to notice is that if I have my function, I'm going to call my function f of x equal to 1 over 1 plus x, like this. And my goal is to write this as a power series. Write this as a power series. Okay. And what I will notice is that this is the same thing as 1 over 1 minus negative x. So I had referenced this idea of a substitution trick. The part that we're going to actually substitute is this negative x right there. Okay, so what I'm going to do is I'm going to basically take my geometric series and I'm going to substitute that in. So I'm going to have the summation as n goes from 0 to infinity. And instead of writing x to the n, I'm going to write negative x to the n. And the way that we're going to we're going to express that is we're going to write it as the summation as n goes from 0 to infinity. We're going to separate out the negative from the x. So this will be negative 1 to the n and then x to the n. So I want you to notice that we have an alternating term over here. So this is an example of an alternating series. Since this is my answer, I'm just going to highlight this answer here. And I was going to make some comments. So I guess the first thing I could say is that we could write out what the terms of this series look like. So it's going to be 1, then minus x, then plus x squared, then minus x cubed, and so on and so forth. And the general term was negative 1 to the n, x to the n, and it goes on forever. Okay. The second thing I want to mention is that the radius of convergence is going to be 1, and the interval of convergence is still going to be from negative 1 to 1. Let's take a look at another example. Let's take a look at example 2 over here. Okay. So when I look at an example 2 is 1 over 1 plus x squared. And we want to basically find a power series representation for this. So what we're going to do is we're going to, you know what, the function we're trying to describe is a power series that's 1 over 1 plus x squared. And I'm going to use a very similar trick to what I did last time. What I did last time was I used a substitution trick. So I rewrote this as 1 over 1 minus. And then whatever I write here next should make it this series equal to f of x. So I hope you can see that if I just if I just consider negative x squared, if I put that in parentheses, then 1 over 1 minus negative x squared is the same thing as 1 over 1 plus x squared. But now this kind of has the same shape as the sum of a geometric series. So when I go to describe my geometric series is the summation as n goes from 0 to infinity. And we're going to have a negative x squared quantity to the n power, like that. Now this can be simplified. This can be simplified to be, we can separate out the negative piece, so it's going to be as n goes from 0 to infinity, negative 1 to the n, x to the 2n, like that. And I'm going to highlight that because that's our power series representation for our function, f of x. I can write out a few terms of this series just so we know what it looks like. It's 1, there's going to be minus x squared, then plus x to the 4th, minus x to the 6th, so on and so forth. Negative 1 to the n, x to the 2n is the general term, and it goes on forever. Okay. Now, we could find the radius and interval of convergence. Let's do the radius of convergence. So the radius of convergence, how is that going to look? Well, we know that for a geometric series, it converges when the absolute value of r is less than 1. Now, our r is negative x squared, so this inequality becomes the absolute value of negative x squared is less than 1, right? And we know that this, we take absolute value of a negative, it just becomes positive. So you got absolute value of x squared is less than 1. And taking the square root of both sides, this tells us that absolute value of x is less than the square root of 1, which basically means that the absolute value of x is less than 1. So we can see that this is a series that's centered at 0. So this means that our r is equal to 1. All right. If you went ahead and checked the endpoints, you would see that the interval of convergence is going to be the open bracket -1 to 1. All right, everyone. We will look at more examples of this substitution trick in class. Take care.